which sort of dictates the way software development should be done. Mainly where it contrasts with the waterfall model is that in Agile, change is welcome. And this should be done, and this should be delivered frequently. And it's done in blocks of time, which usually lasts somewhere between 2 to 4 weeks. Whereas with the waterfall model, the change, even though it may be simple to integrate, won't be delivered until the whole product is complete, which could take several months, a year or so. So we have now evolved into a better way of producing software with the Agile methodology, which allows us to add new features and changes really fast compared to the previous ways of working. That is, at least in our local environment or our own machines. But what if we wanted to test our code in an environment that resembles the real-world production environment? What if we already tested it and we were ready to deploy it to the production environment? Well, we would have to wait for the operations team to be ready as well. And this could slow down our process several business days, if not weeks or months, depending on the availability of resources, whether that is physical space in a data center, storage, memory, CPUs, in the case of virtual machines, or even enough hands to set things up. This area of improvement is what sparked the keyword DevOps, which has its origin at the Agile conference back in 2008, where 2 engineers named Andrew Schaefer and Patrick Dubois had a conversation about how infrastructure teams could become as agile as software development teams. This became known as Agile Infrastructure, and the years after, Patrick Dubois started organizing events that he called DevOps Days. And this is how the word DevOps, how that keyword originated, and how we ended up with diagrams similar to the one we're seeing in the current slide of the presentation. This is not a class about what DevOps is, so we'll just briefly go over the DevOps lifecycle, in which there are several stages that make it up. And to start out, to the left side, top left, you will notice stages that are more oriented towards the development teams, such as source code development, compiling or building, tests, such as unit testing, source code analysis, or static application security testing. And to the right side, you will notice more stages related to the infrastructure and operations side, such as deployment, where you employ different strategies to avoid downtime or allow rollback easily. Operations, which involves maintaining the infrastructure and ensuring resources are available when needed, keeping everything up to date, and so forth. As well as monitoring, where you review logs, metrics, and traces, and set up notifications, alerts, and automation to ensure resources are stable and reliable. While in the middle, we have planning, as both teams, Dev and Ops, participate in the stand-up meetings where they keep the team up to date with any challenges and status of what they are working on. And of course, in the middle, we also have the release stage, where the role of developers is to ship the changes, and from where the operations team can pick up and deploy these to different environments. We can group several of these stages into a couple of phases, and these are continuous integration, which covers mainly code and build, though I would argue that it also covers testing, as you perform some tests there as well, to detect vulnerabilities, linting, bugs, and all that. And the phases known as continuous delivery and continuous deployment have just one difference. And well, I like to call them as just one thing, continuous delivery and deployment. And the difference between the two is that the deploy stage is automated in the continuous deployment phase, meaning as soon as the change has been reviewed and accepted, it will go forth and automatically deploy the change. While with continuous delivery, it actually stops right there, and someone has to come in and manually launch the job for the deployment to complete. And while the other phase that's pending is the continuous feedback or continuous planning. And while this last phase is all about communication and sending alerts, notifications, whenever an issue is identified through monitoring or sharing feedback with the team during the planning phase. There is a concept I fully agree with, which is called DevOps as a service. And this is mainly those tools or platforms that go just beyond the CI/CD pipelines. These applications provide the necessary tools to cover all the stages from the DevOps lifecycle, such as a tool for the planning phase, which could be a tool that keeps track of all the work items and issues in a table known as backlog, a tool to put these items into sprints, which are merely just defined blocks of time that usually range from 2 to 4 weeks, and boards to easily visualize the items in the sprint. Another really important tool is a version control repository, which is usually based on Git nowadays, where everyone working on their code pushes the changes into an application such as GitHub or GitLab to share and collaborate with others as they develop their code. And we also have pipelines as well, which are defined in a YAML file, at least in the platforms that I put together in this slide. And in these files, you dictate the stages or jobs that will make up part of your pipeline, as well as the scripts or steps that will be executed in these jobs. We also have agents, which are also known as workers in some other applications or runners. And these are the actual machines that will pick up the code from the repository to execute the instructions inside the jobs of the pipelines. And they also have other tools, such as tools to host packages for a variety of programming languages, as well as a container repository for container images, artifacts, which are just files that are produced by the build jobs by all the jobs of the pipeline. You also usually have environments that you can set up to know where you're deployed to. Also some other tools to scan the code for vulnerabilities and changes and so forth. And as we all know, the tool that we will be focusing on in this lesson is GitHub and Github Actions. GitHub, just like the majority of applications that provide version control, is based on, you guessed it, Git. Therefore, the next step in the development stage would be to use a version control software or source code management software, as it is also known. This is essential if you're in a team of several developers, mainly because it will allow you to work on features separately by creating branches from the main branch, the repository for each feature that everyone is working on. And also, it enables distributed development, as every developer will have a local copy of the repository with its history of commits. Even if you are not in a large team, you will see benefits of using Git. It is really helpful because it tracks all the changes and history of the repository. So it allows you to easily roll back to any previous changes, and it allows you to keep your changes organized, as opposed to having several versions scattered all over the place with suffixes such as final, test, final version 2, and so on. Surely, I'm not the only person guilty of doing this, and you can see an actual screenshot of an example of some folders I had before I started using Git. And another great feature of Git is that it will allow you to compare changes done from one commit to another to see what changed between them. So I'm going to go ahead and run a poll right now to see how much experience everyone in the class today has, how much experience everyone has with Git, to see how deep we can dive into this, or if we can just skim right past it really briefly. So if you could answer the poll right there, that would be awesome. To leave that there for a couple of seconds. All right, now I'm going to go ahead and push the results. And we have few people with basic and people who don't know what Git is, and the majority are intermediate to highly experienced on Git. So I was asking because the next part is some Git commands. So I'm just going to go past them briefly. And well, starting out, when you prepare your Git installation in your computer, in your system, you need to tell it who you are and what your email is, so that whenever you commit, it tags those details in that commit, so it knows who made the commit. And another important Git command is the remote command that you see right there. And that is basically how you link a remote repository to the local repository in your system. Another important Git command is init, in which you initialize a repository in the directory where you're currently standing in your system. And the most important one, I would argue, is clone, which allows you to clone a repository into your system. And there is an example of how you would clone a repository right there. The reason I'm skimming pretty fast through these is because we're not really going to use many Git commands in our exercises today. And there are also some great Git courses from others here in O'Reilly. So I would suggest you take classes with some of those folks, which are really good. And well, another important command is add, which allows you to add a file to the repository so that Git can track it. And when you commit it, it actually gets a hash and gets added to the history of the Git repository. And with status, you can see the list of the files in your repository. You can see which files are staged, which are tracked, as well as which are untracked. And branch is how you create branches in Git. Checkout is how you change branches in Git. And the merge command is when you want to merge a branch with another branch. And the following are commands to push changes to a remote repository, or pull them, or just fetch them and not integrate them into your repository. And well, this brings us to the Git workflow. And basically, this is what is known, or what we're going to use here is the GitHub flow. And this is helpful to have everyone that's collaborating in the project to be on the same page on how Git will be used. It is also known as Git strategy or branching strategy, or just Git workflow. This is where you dictate what branches will be used in your repository and how they will be used and merged. We're going to use a really simple Git workflow, which is the GitHub flow. I know there are a couple of strategies, but since this is a GitHub course, we're going to be focusing on this one. And it's a lot better for everyone because it's really, really simple compared to the other options. This type of Git strategy has no concept of a release. So here you can see in that diagram right there, there's no release or hotfix branch right there. It's just easy, plain and simple. At least when compared to Git flow, which has all those branches in the Git strategy. This also makes it easier for newcomers to adopt, as all you have in this strategy is a main branch, which you can see right there, which is also called trunk on other similar workflows, trunk-based development, for example. And the idea here is that you will be creating very short-lived branches, either for hot fixes or new features or a change that you would like to add into your project. The goal here is to commit multiple times per day, and that is actually a mantra for the continuous integration phase in DevOps, and that is commit early, commit often. I have seen complicated issues because a developer was holding back on pushing their changes, and they did so after a couple of weeks or a month, I think it was. And well, they pushed hundreds of changes, and they ran into so many merge conflicts that wasn't really fun to. The merge pipeline didn't even run because it had issues, and I guess it took him more time to go through everything. So ideally, you want to commit early and commit often, so you can avoid these type of issues and several others. And to go over this diagram really quickly, you can see we start out from the main branch with the first commit. Then we create feature branches, the feature X and feature Y branch, where we have a couple of commits where, say, we're working on a new authentication feature or a contact form or a chatbot or something. And we work on that in its own branch, and we start merging it almost on a daily basis as soon as you have changes, or if it's ready, just commit the whole feature branch and delete the branch when you no longer need it. So we have reviewed what Git is all about and how a version control system works. And we get all of this with GitHub, which is mainly the continuous integration part of the DevOps lifecycle. But we also have GitHub Actions to cover the other part of the DevOps lifecycle, which is the continuous delivery and deployment phases, which we will review towards the end of this live lesson. In short, with GitHub, we have a version control repository where the people collaborating in our repository will be merging their code changes to enhance our application with new features, optimization, and whatnot, as well as fixing any issues that they may have encountered or that someone reported. While with GitHub Actions, we can take our repository to the next level by setting up pipelines that will automatically run some scripts either to review our code changes or deploy these new features or fixes into a production or test environment. So this was the theory part, and we'll be starting out that we can include in our repository, among others. And here at the top right, we have this plus sign, and this is where we can create a new repository. We can import a repository, create a gist, which is basically a snippet of code. We can set up a new project or organization. So let's go ahead and click on New Repository. Let me have a look at the questions and attendee chats. I see a lot of action there. We can include in our repository, among others. And here at the top right, we have this plus sign, and this is where we can create a new repository. We can import a repository, create a gist, which is basically a snippet of code. We can set up a new project or organization. So let's go ahead and click on New Repository. Let me have a look at the questions and attendee chat. Viewed what Git, GitHub, and GitHub Flow are. And well, Git is a distributed version control system. GitHub is a cloud-based code hosting platform for collaboration and version control. And GitHub Flow is the branching strategy or Git workflow. Now, when it comes to actions, an action in GitHub is actually a predefined task that performs something, such as build a container, deploying to Kubernetes, logging into your cloud provider, accessing storage, pushing an artifact, and so forth. It's not the actual pipeline itself. It's just those actions to do something, or tasks as they are called in Azure DevOps. And well, speaking of DevOps, GitHub doesn't even use the term pipeline. Instead, it uses workflow, as the idea for using this tool is to automate anything, not just integration and deployment. So within this workflow, you would be running these sort of like plug and play tasks called actions, or your own custom scripts. And if you're wondering how these workflows are executed, well, for that, we have some machines called runners that I mentioned a couple of slides back. And what is a runner? A runner is a machine that has the GitHub runner application installed, which makes it capable of executing some of the workflows in your repository. And I mentioned some because some workflows will only be able to be executed by certain runners, depending on the OS, operating system, or tools installed in it. Someone said if I'm on mute, anyone is not able to hear me? Hello, hello, hello. No, I see the microphone moving. Yeah. It could be your speakers. All right, so I was saying that the runner is the machine that executes the jobs. And well, it depends on the operating system. It depends on the operating system, the jobs that it will be able to pick up. For example, if you have a runner with the... Thank you everyone for letting me know that I am audible. So someone has issues, just remember, just refresh the browser. Most of the issues go away with that. So as I was saying, if you have a runner with a Windows operating system, you will not be able to execute jobs that require Mac OS or Linux, or even if the architecture is different. For example, some could require ARM, and you could have a runner that is on 64-bit and they're not x86, so they wouldn't be compatible. Those jobs wouldn't work on that runner. So basically, if your runner does not have the tools necessary to execute certain programming languages or tools it needs or the operating system, then it won't be able to execute the job, and vice versa. Fortunately, GitHub provides several runners which are free of charge. If you're working on public projects, that is, to promote open source, and also provides thousands of minutes in the free tier for private projects. You can also host your own private runners, also known as self-hosted. We will see a lab on how we can set one up. And having your own self-hosted runner allows you to have more control by having dedicated resources for your job, for your pipelines, for your repositories. The main difference between the GitHub hosted runners and the self-hosted runners is that with the self-hosted runners, you no longer have to worry about the consumption minutes for private repositories. But on the downside, you have to worry about managing and maintaining your self-hosted runner by yourself, such as keeping everything within it up to date and fortifying it, like making it secure and so forth. And there is a list in the documentation of GitHub that shows you all the details about the runners. I will go ahead and open that up in the virtual. Well, how do we create the workflows? Well, we need to learn a language called YAML. And basically, YAML is a language that is used to format and represent data. And it's very similar to JSON. But actually, when I started learning YAML, I really hated it because I came from a JSON background. But you'll get used to it and you'll start liking it more than JSON, trust me. And well, as you can see in the slide right there, it's a superset of JSON, and it has human readability in mind when compared to JSON. When everyone talks about YAML versus JSON, everyone mentions that JSON is basically a language like focused on getting machines to understand, while YAML is more oriented for humans, like for humans to be able to read it. So YAML came out in 2001. Something curious about it is that back in the days, it used to stand for yet another markup language. And it was later changed to YAML ain't markup language to emphasize that it's a language intended for data and not documents. And well, one of its huge advantages is that it's easy to implement and use. Yes, right now I'm sharing a slide. If you're not able to see it, I would recommend you refresh the browser. Right, so YAML has also been used to configure applications. Some of the applications that are well known and use YAML are, for example, Ansible, Kubernetes, CloudFormation. Almost everything related to infrastructure as code nowadays is using YAML. It can also be used to import, export, or store data from a server, as well as transferring data from two components of an application. When writing a YAML file, one of the most important things you need to look out for is indentation. It uses indentation instead of brackets, kind of like the way Python does. And one thing to note is that, well, it allows tabs, but ideally you should use spaces. I like using just 2 spaces, and you will see that throughout the labs. It's a lot easier to manage. And well, here you can see an example on the left side on how indentation works. You can see we have the job map followed by the first job, which is a property of jobs, or basically a key that is part of jobs. And you can see that it's intended to let us know that it is part of jobs. It belongs within it. And within that first job, we have the runs on, which is basically a property to tell it that we want to run an Ubuntu latest image runner with that image on that job titled first_job. In YAML, unfortunately, we cannot comment multi-line, so we have to put one of those hash symbols before every single line we want to comment. And the supported data types in YAML, as you can see right there in the slide, are nulls, numbers, strings, arrays, booleans, maps, and so forth. And to define a variable, well, it's really easy. Just provide the key. In this case, you can see the example. The key would be the name of the variable, which is variable in this example. And it's followed by a space, well, a colon, then a space, and the value. And the way you define a list, someone mentioned that font is very important to visually recognize the indentation. That's true. And that's something I like about Azure DevOps, is that it puts little dots between the spaces, so you know how many spaces between each indentation. And I haven't seen that in GitHub yet, or maybe I haven't found how to turn it on, but that's really helpful, at least in that case, to visually recognize the indentation. So the way you define a list in YAML is by creating the key, and the way you add each element is by adding a dash and a space to each of the following lines. Elements will be added to the list as long as you keep the indentation in place. All right. So there are 2 ways to represent a list. One is with the block syntax, which is the one you see right in the middle that says variable, enter 1, 2, and 3, or 3 lines. And the other one is the square bracket syntax, which might be more visually pleasing for those who are still used to JSON. You can also create dictionaries in YAML, and this is done with the help of indentation as well. Everything is done with the help of indentation in YAML. So basically you add a key followed by a colon and a space to set up a map. And here's an example of one of my cats. We have the cat object, so to say, and the properties within it. And well, you may be thinking that this is the same as a dictionary or object, but the difference between the two is that the order is maintained in map. So that's why it's called map instead of object. Nesting in YAML, well, what you can do here is you can nest maps in maps, lists in maps, maps in lists, and so forth. And you can create very complex structures with that. You can see in this example right here, we're combining a dictionary, well, actually a map, which also has another map inside. So it's first we have the map called cat, and this has another map inside called characteristics, and it also has a list inside called activities. So you can see we can create a complex structure like that. So now we're going to see how we can work with our workflows. And well, basically we saw in the previous exercise how we clicked one button and it took us to an editor to create a workflow. So basically that file is stored in that directory you see right there, which is at the root of your directory. And it's called .github, which is the first path, and then -workflows. And followed by that is the name of the workflow files that you're going to have in your repository. And well, basically a workflow file is a file made in YAML, and it defines the jobs and steps within your pipeline. The first keyword we will learn about within the workflow file is the name keyword. And it's actually very simple. It is just the name of your workflow. If you omit this keyword, then the name will be the path of your workflow file. So yeah, it is useful to use that keyword. And next we have the on keyword. It is actually one of the most important elements of your GitHub workflow file, as it specifies a trigger that will initiate the workflow. The most common triggers are push, pull request, scheduled, fork, and issue. And one example would be if someone makes a change in your repository, and you have a workflow with the key on, and it's set to push. Upon making that change or pushing that change, the whole pipeline or workflow will be executed. In our labs, I set up another event, which is called workflow dispatch, and that just makes the workflow run manually upon demand. And we'll see that in the exercises. And well, I'm also going to go ahead and open the link that includes assigned to that particular job. You can configure jobs to divide your workflow into several activities. For example, you could have one job focused on building a container, another job to deploy to test, another to production, and so forth. And you can also dictate the runner that will be executing the job by using the runs on keyword. Normally, jobs, you would use them to deploy two pipelines at the same time or two apps at the same time. While in other tools, for example, in GitLab, you do have everything like divided. Like you have a job for build, another for test, another for deploy, and so forth. Here you can have it all in just one job and several steps. And I think that makes it a little bit faster compared to the other way, as the other jobs have to be picked up by a particular runner. And here you have one for all those steps right from the start. So you can set that up in the others as well. So it's just a matter of preference and organization, I would say. So jobs are defined within the jobs keyword. So you have a keyword that says jobs, and within it you have all these other jobs, all right? And each job within it is identified by a string, and its value is a map, as we saw previously what a map is in the YAML section. And well, yeah, as I was saying, map is sort of like an object. And the difference between a map and an object is that the map, the sequence in which you insert elements into that map, it's iterable, but the order is maintained. And in an object, the structure is not maintained, which is why we require that for workflow files or pipelines and so forth. You can also give your job a name besides the ID, and to do so you use the name keyword, just like we mentioned in the workflows. You can also specify the runner that's going to be running that particular job with the runs on keyword. And this is useful to specify if you want to use your own self-hosted runner or one of the GitHub hosted runners, as well as a different OS version, which is declared with the runner image. And within a job, we can run steps, which is where all the action begins. This is where we run commands, tasks, and actions. And this is defined with the steps keyword. And we use a dash, sort of like how we do with lists in YAML, to define the block of code for a step. In each of these steps, we can make use of several keywords, such as name, which is helpful to identify the step. You can also use ID to reference it in other parts of your code, and so on. Another really useful keyword is shell, and it helps you override the default shell of the operating system of the runner that is executing the job. For example, you can switch from PowerShell to CMD or Python in a Windows runner. And the run keyword runs commands in the operating system shell. And another something I'd like to highlight here is that you can run the run command in a single command, but if you use the pipe symbol after run, we will see that in the exercises, you can run what is known as a multi-line command. All right, and that's going to take us to exercise number 2, where we're going to set up a runner and the basic workflow.